Welcome to the 9th chapter of the Pearson Geometry video series. This first lesson discusses polygons in the coordinate plane. When we work with the coordinate plane, we will be working with formulas that use ordered pairs. Take example 1 for instance. They are asking for the distance between 2 points, right here and right here. The distance formula is cumbersome, but it always works. So we can say distance equals the square root of, let's make that x1 minus x2 squared plus y1 minus y2 squared, and then we want the square root of the whole thing. If you have nice neat numbers, Pythag is a friendlier version. So we can go down, straight down, and straight over, make our right triangle. And we're going to have 5 units up and down, 2 units across. So that means 5 squared plus 2 squared. And we want the square root of that, which is going to give us the square root of 29. So the distance from A to B, or the length of line segment AB, is the square root of 29. Okay, we also want to find out what point bisects AB. Okay, so we've got the midpoint formula. If we use the midpoint formula, we add the x's together and divide by 2. So 1 plus 3 is 4, divided by 2 is 2. And then 6 plus 1 is 7, divided by 2 is 3.5, or 7 halves. Okay, so if we're using Pythag, because we have nice neat numbers, it works for this as well. So if I take the total length up and down, the vertical length, and take half of that, I'm here at about 2.5. If I take the horizontal length, half of that would be 1 unit. So where these units go up and over, that's where they're going to coalesce at the midpoint of AB. And if you look at this starting from 0, we're going to go over 2 units, which is what we said here. And we're going to go up 1, 2, 3.5, which is what we said here. So we're still kind of using Pythag in order to figure that out. Okay, now in example 3, we know that perpendicular lines have opposite slopes, and right angles are made from perpendicular lines. So if AB and BC have perpendicular slopes, then that means that triangle ABC is a right triangle and angle ABC is a right angle. So let's go ahead and figure out the slopes of those. Starting with going from left to right, and starting with AB, we're going to go down 5 and over to the left. So that's going to be, so the slope of AB is going to be -5 over 2. Okay, now let's find the slope of BC. So the slope of BC, we're going to go up 2 and right 5. So that's going to be a +2 over 5. And you can see that these are, in fact, opposite reciprocals, so they must be perpendicular slopes, which means that angle ABC equals 90 degrees. Okay, example 4. We're going to use this triangle down here. It's the same one, but that's okay. And we are looking at the line segment connecting the midpoints of AC and BC, which is shown right here. Okay, so if this is a midpoint and this is a midpoint, then that makes this a midsegment. And a midsegment is halfway between the base and the top of the triangle, which means that we're going to find it the same way that we found our midpoint up here. We're going to average the bases, or in this case, since this is 0, we're going to take half of this. So we already figured out, using Pythag, that AB is equal to radical 29. So if we want to know what the midsegment is, and we're going to take half of that, then the midsegment is going to be equal to 1/2 radical 29. All right, let's look at classifying triangles. We're going to classify triangles, and then we're going to classify quadrilaterals, and then we're going to classify kites and trapezoids, and we're going to use these algebraic formulas in order to do that. Okay, so XYZ, is it a right triangle? Just looking at it, it looks like if it is, this is going to be our right angle right here. So we're going to want to figure out what our slopes are. So if we figure from X to Y, we're going to go up 1, 2, 3, 4, 5, 6. So the slope of XY is going to be up 6 and over 1, 2, 3, 4. So 6 over 4, we'll go ahead and reduce that to 3 over 2. Okay, the slope of YZ is going to be up, let's see, we're going to go 1, 2 down, and 1, 2, 3 across. So negative 2/3. So it looks like this is a right triangle because it contains a right angle. So yes, triangle XYZ is a right triangle. Now, another way that we could have found this, if we were to find the length of these sides and say a squared plus b squared equals c squared and discovered whether or not that was a true statement, that would also have worked. All right, let's take a look at example 6. So with, well, let's see, the vertices of PQR are 4, 1, 2, 7, and 8, 5. We want to know if it's equilateral, isosceles, or scalene. So we need to know the lengths of the sides because we need to know if all 3 are the same, 2 of them are the same, or none of them are the same. So we're going to use the Pythagorean theorem to figure out the sides. Okay, so let's start with this one right here. Okay, so if we look at this side right here, we're looking at 3 and 2. Okay, so well, let's see. This is going to be YZ. So YZ is equal to 3 squared plus 2 squared, and we'll take the square root of that. No, wait a second, that is not even the one that we want to use. That would go with this one right here, and we already checked that one. So before we do this one, we're going to have to draw a triangle so we can see what we're working with. Okay, or let's try and do it without a triangle. Okay, so we have from, let's start with PQ. Okay, so from PQ, we go from 4 to 2, that's a difference of 2, so we'll say 2 squared. And then from 1 to 7, we're going to go 6, so that's going to be plus 6 squared. And we'll take the square root of that, which is going to give us about the square root of 40. And we don't have to reduce that because we just want to know if the sides are the same or not. Okay, now let's try from Q to R. Okay, so difference in the sides. So from 2 to 8, we have 6 squared plus 7 to 5. The difference is 2, so we're going to say 2 squared. And some of those are positive and some are negative, but when we square them, it makes them all positive. So I just figure out the absolute value of the difference between them. And for this one, we are also going to have the square root of 40. So at the very least, we're looking at an isosceles. Okay, now let's try PR. Okay, so from P to R, we're going to go 4 to 8. That's a difference of 4, so we'll say 4 squared. And we're going to go 1 to 5, which is another 4 squared. Okay, so we're looking at 16 plus 16, so the square root of 32. Okay, we have two sides that are congruent, so we're going to say that this is an isosceles triangle. Okay. All right then. Last one on this side of the page. Is PQR a right triangle? Okay, so in order to figure that out, we need to know what the slope is. So we're going to go take the y's first. So if we go 7 minus 1 is going to be 6, and 2 minus 4 is going to be negative 2, which equals negative 3. Okay, so that was PQ. Okay, now let's do QR. Okay, so 5 minus 7 is negative 2, and 8 minus 2 is 6, which equals negative 1/3. Okay, and now P and R. Okay, so we're going to do 5 minus 1 is 4, over 8 minus 4 is 4, which equals 1. Okay, so if it's a right triangle, then two of our slopes are going to be opposite reciprocals. So we know this one's not involved. So we have negative 1/3 and we have negative 3. If this was positive 3, or if this was positive 1/3, we'd have a right triangle, but there are no perpendicular slopes. So we're going to have to say that this is not a right triangle. Now, if we wanted to know what it was, we could find all the lengths of the sides, which we have right here, and then put them in the Pythagorean theorem and see if it's true. And if our hypotenuses are bigger than they're supposed to be, then it's going to be an obtuse angle. If they're smaller than they're supposed to be, then it's going to be an acute angle. Okay. Alrighty, so let's look at classifying parallelograms. Okay, so let's slide this down where we can see it. Okay, the vertices of a parallelogram are negative 2, 2, 4, 6, 6, 3, and 0, negative 1. All right, now that we're dealing with four ordered pairs, it's probably going to be easier if we go ahead and sketch what we have. So I'm going to draw a quick graph. Okay, and the more precise you can be, the better. Okay, so we're going to need at least 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. There we go. Okay, so we've got negative 2, 2. So we're going to go back 2 and up 2. And that's going to be A. And then we're going to go right 4, 1, 2, 3, 4, and up 6. So up to here, that's going to be B. And then C is going to be right 6 and up 3, 1, 2, 3. And D is going to be 0 and negative 1, which is right here. Okay, so this one's D and this one's A. All right, let's go ahead and connect those points. So far, all we know is that we have a quadrilateral because it has 4 sides. Okay. Now, looking at this, we want to figure out if it's a rhombus. Okay, so we know it's a parallelogram because they've told us that it's a parallelogram. All right, so what do we know the difference between a parallelogram and a rhombus is? Okay, if you said that all of the sides of a rhombus are congruent, then you would be absolutely correct. So what we want to know is, are the sides of this parallelogram congruent, all 4 of them? And actually, we can look at this one and tell that they're not going to be congruent. So we can say that AB and DC are not the same length, AB and DC are not the same length as AD and BC. Okay, and we can tell that from the picture. It's pretty clear, even if it wasn't real consistent, but this is actually a fairly consistent graph. Okay, now we want to know if it's a rectangle. Okay, how do we tell if it's a rectangle? Well, if you go back to the ones we did on the other side, we need to know if we have any opposite reciprocal slopes. So let's go ahead and figure out what our slopes are. So from, let's see, AD is going to be down 3 and over 2. So that slope is -3/2. And BC is going to be equal to down 3 and over 2. So we know that those are parallel. And then AB is going to be, let's see, up A to B. Let's 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6. Okay, so 4, 6, let's round it to, or simplify it to 2/3. Okay, and DC is also going to be up 4 and over 6, so we'll round that one to 2/3. Okay, so we know that from here that AB is parallel to DC and AD is parallel to BC. And then we also know that AB is perpendicular to AD and DC is perpendicular to BC. So we would have to say yes, ABCD is a rectangle. Now, some other ways that you could figure this out. The other thing that we know about a rectangle that is not necessarily true for any other quadrilateral, except maybe the isosceles trapezoid, is that its diagonals have to be congruent. So we could figure out the length of the diagonals, again, using the Pythagorean theorem, or it looks like with AC we can just count. And if those are congruent, then we would also have to say that ABCD is a rectangle. Okay, moving on to kites. Let's take a look at example 8. So we want to know specifically if this is a quadrilateral, if it's a kite, a trapezoid, or neither. Okay, so for a trapezoid, it would have to have 2 parallel sides. Okay, so I'm looking at this, and these are not parallel, and these are not parallel. So it's either a kite or it's neither. If it's a kite, these 2 sides are going to be congruent, and these 2 sides are going to be congruent. So we can look at this one, 1, 2, 3, 4, and that one is 4, and 1, 2, 3, 4, and that one is 4. So we just have to figure out if these are congruent. And we're going to do that using Pythag and right triangles. Okay, so this one over here, we're going to go over 1 and up 1, 2, 3, 4, 5. Okay, so we're looking at 1 squared plus 5 squared, and we'll take the square root of that. Okay, so 1 and 25 is 26. Okay, so that's what that one is. Okay, now let's look at this one. Up 1 and over 5. So we're looking at the same thing. So that's also going to be equal to radical 26. So it looks like these are congruent and these are congruent. Not all to each other, but at least the 2 sides are. So we would have to say that this one is a kite. All right, looking at example 9, we want to figure out same thing. Is it a kite, a trapezoid, or neither? Okay, so the easiest way to figure this out is to see if it has a set of parallel sides first. Okay, because kites don't have parallel sides. So with this one, if we figure out this slope right here, it's going down 1 and over 2. Okay, so that slope is going to be and that's WZ. So the slope of WZ is equal to negative 1/2. All right, now let's try this one over here. So this one is going down 2/3. So the slope of XY is equal to negative 2/3. Okay, so these aren't parallel. And these don't look parallel, so we know we have no sides that are parallel. So that means that we have to have two sets of sides that are congruent. So that means that this side and this side, and this side and this side. And we don't have two consecutive sides that are congruent either. So we're going to have to say in this case that it's going to be neither. All right. So we are finally on perimeter and area, and we're going to get into this in a little bit more in the next video. So right now we want to figure out the area and perimeter of a quadrilateral WXYZ. So since we have this empty graph, let's go ahead and sketch it. So W is going to be over 5 and up 4. So over 5, 1, 2, 3, 4. There we go. And X is going to be over 2 and up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I guess I could just use these numbers on the side too. Y is 9, 9. So right here. And Z is 8, 4. So 1, 2, 3, 4. Okay, let's go ahead and connect those points. Okay, and the last set. Okay, and it's always a good idea to label them too, because if you have to identify something like the slope of one of the lines, that way it's going to be easier to tell which one you're talking about. Okay, so now we have them all labeled. All right, so we want to know what the perimeter is. So up here at the top, basically perimeter is when you just add up all the sides. So 2 of these sides are easy. So we can go ahead and count 1, 2, 3, 4, 5, 6, 7. And down below 1, 2, 3. Okay, so we've got 2 of the sides. And of course we're going to use Pythag to figure out the other 2 sides since they're at a slant. So we've got 1, 2, 3, 4, 5. So 5 squared plus 1, 2, 3 squared. Okay, and then we're going to take the square root of the sum, which is going to be 25 plus 9. So we're looking at radical 34. Okay, and if we figure out what radical 34 is, then we'll be able to add all of these together. Let's try the other one first. Okay, so now we've got 5 squared again, plus 1 squared. So we're looking at 25 plus 1 is 26. Okay, so our perimeter is going to be 7 plus 3 plus radical 34 plus radical 26. And we don't want to leave this in radical form because perimeter is more of an application, and we've talked about that before. But when you go ahead and put this in your calculator to add it all up, you're going to leave it in decimal form, but you'll have to round it a little bit. So if we round it to the nearest tenth, it's going to be about 20.9. And that's going to be our perimeter. Okay, now looking at the area, this is a trapezoid, and so we want to do base times height. Okay, height is easy enough because height is going to be about 5, same as it was on the outside triangles. Okay, as far as the base goes, we have this base, which is too big, and this base, which is too small, so we're going to average them. So we have 7 plus 3 is 10, and then when we divide that by 2, we get 5. So our base, which, okay, our area would be 1/2 base 1 plus base 2 times the height. Okay, so when we average them, that's what the 1/2 base 1 plus base 2 is. So we want 1/2 of 10 times 5, which is going to be 5 times 5, which is going to equal 25 units squared, and we'll say 25 units here. So perimeter is 20.9 units, and area is 25 units squared, and that is about enough for this video. See you later.